Hello again, students. Welcome to my YouTube learning channel. My name is Gillespie, and this channel is for students who are doing either geography or social studies in high schools. In this particular teaching video, which was specifically created for students of third form who are doing third form CSEC geography, expect that you will be learning the basics as it concerns the subject of volcanoes and volcanicity. Now, at the end of this video, among other things, expect that you'll be able to define what we mean by volcanoes and volcanic mountains, and to be able to distinguish between those two concepts. You should be able to also describe in basic terms what causes volcanoes to be formed, or volcanic features, whether above the ground or under the ground, what causes volcanoes to erupt, and of course you should be able to give examples of major volcanic areas, volcanic zones, and examples of course of active volcanoes in the world and where they are located, and of course in those volcanic zones and areas to be able to identify some of the other features apart from volcanoes which are found either on the surface or below the surface. And so to begin this topic, let me now take you to a video which will introduce in basic terms what we're about to deal with.
Volcanoes are our most explosive landforms, able to eject molten rock and clouds of thick ash high into the atmosphere, with devastating consequences.
Now, seeing that I am dealing specifically, or more so, with students of Jamaica and students in the Caribbean, let me start off by bringing this closer home to our Caribbean and Jamaican experience. And I'd like to introduce to you what has been in the news, very topical in the year 2021, when this video was created. And in the month of April, March coming through to April, we had our own very topical, newsworthy volcanic activity and experience right here in the Caribbean, in the island of St. Vincent. And so let me take you now to a little recap as to what happened or what has been happening in 2021 in terms of volcanicity and volcanic activity in St. Vincent.
The lush Caribbean island of St. Vincent transformed into a grey, gloomy moonscape. Streets and buildings blanketed by ash spewed from a nearby volcano. La Soufrière ended decades of inactivity on Friday when it erupted in spectacular fashion. There were several earthquakes, and a column of ash was pumped up to 15 kilometres into the air.
We don't know how much more is going to come out, but it is plenty. It's coming out.
And it's hampering the escape of thousands of people who are now in shelters across the island.
I am scared. I'm just hoping for the best so that everything can be over so I can go back home.
La Soufrière means sulphur outlet. It's the only potentially active volcano on St. Vincent, which is home to about 100,000 people. Ash from the eruptions rained down on several neighbouring islands, including Barbados, nearly 200 kilometres away. Countries including Venezuela, Cuba, Guyana and the United States are sending aid to the island nation. Cruise ships have been sent in to help those fleeing the eruption, but because of the pandemic, anyone going on board will have to be vaccinated, and everyone in a shelter will be tested for COVID-19.
This is the second time I'm experiencing the volcano. The first time it erupted, I was 9 years old.
There have been 5 explosive eruptions on St Vincent in the past 300 years, the most recent in 1979. While there have been no deaths reported this time, an eruption in 1902 killed more than 1,000 people. But damage to crops and farms from the choking cloud of ash is expected to be severe.
We are agricultural based community. And if this is going to be for the next 3-4 months, life will be very difficult for people.
And experts say the eruption could continue for some time yet. Alexia O'Brien, Al Jazeera.
Okay, students, so there you have a little background into the reality of volcanoes right here in the Caribbean and some of the effects that volcanoes can have. They are real. This is not a textbook thing. This is real life as you go about your daily living right here in the Caribbean. And so let me just simply take you a little bit more, maybe another minute or two, into the harsh realities of what volcanoes can do to the life of people right here in the Caribbean.
Now, the Caribbean island of St Vincent has been rocked by a huge explosion as the La Soufrière volcano fired a plume of ash and hot gas into the skies. Officials said it was destroying everything in its path, amid fears for the safety of some residents who have refused to obey orders to evacuate. The series of volcanic explosions over the last few days have disrupted food and fresh water supplies, wiping out forests and farmland. From St Vincent, Kenton Chance reports.
In Walliaboo, a community in the volcano safe zone in western St. Vincent, a man uses the time between ashfall to clean up around his home.
Never seen nothing like this before. Heard of it, yes, but never know it would have been of this magnitude. Didn't expect it to be like this, really. Expecting something like just blow and then it's over with. But the kind of, the ash, that is one of the biggest problems, really.
On Friday, after decades of inactivity, La Soufrière volcano erupted, spewing clouds of dense ash almost 10 kilometers into the air. In the danger zone, the sky was turned into night by the ash in a matter of minutes. Tens of thousands of people have had to leave everything and evacuate. The eruption knocked out power and covered homes in a white layer.
The visibility is really low, and now as I speak to you, it's just after 3 in the afternoon, but we noticed because there are stones literally raining down on the vehicle. This is actually a very scary experience.
Cars were left stranded, wheels stuck in the ash. The town of Barley, like the rest of St. Vincent, is covered in volcanic ash. While residents of the town clean up around their properties, at a nearby shop, this farmer enthralls evacuees. He spent 2 nights on the flanks of the volcano after it erupted.
Coconut trees break down. I'm talking about all the coconut trees, all. You see birds on the ground. Yeah, may I tell you, it don't look nice.
Thousands of persons heeded the order to evacuate Thursday evening, hours before the eruption. Many arrived in Barley by ferry from Chateaubriand, the town closest to the volcano on the west coast. Here in the central Leeward town of Barley, many of the residents of Chateaubriand who fled the erupting volcano have found a temporary home in this community. Here they recount their experiences, even as they face the ashfall so far south from the volcano. However, in Georgetown, located in the danger zone on the eastern side of the island, this farmer has refused to leave. He passed Friday night enjoying the local liquor to the sound of volcanic pebbles falling on his roof.
Do you mind if I ask you your name?
My name is Supercat.
Try your best to be safe, but maybe you should follow the order and evacuate.
I'm following the orders.
Evacuate.
To evacuate, but when the time comes.
After all the morning they're talking about, this morning wasn't a nice morning.
I was there. When I talking about the man still like a chat passing, we start to hear, I can be back
I'm wrapping them up. Because we're trying to bring down a little marijuana, because we're not in the marijuana life. But we live in Chattaway and everything, so we're trying to make our livelihood to the best.
Officials say that this eruption of La Soufrière is likely to be worse than in April 1979. 3,700 persons are in 85 emergency shelters and thousands more sought refuge with relatives and friends. With the eruption coming amidst the economic hardship brought on by the COVID-19 pandemic, St. Vincent and the Grenadines could be in for a few rough years.
And Kenson joins us now live from St.
Now that gives us sufficient background with which to work and to understand the reality of volcanoes right here in the Caribbean. Now it's time for us to discover, to delve into what do we mean by volcanoes? What do we mean by volcanicity? What do we mean by a volcanic mountain, for instance? And so let's now delve a little more into the real facts about volcanoes and volcanicity.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at volcanoes. A volcano is a vent in the Earth's crust where molten rock, gas, and steam erupt onto the planet's surface. Volcanoes are most common in areas of seismic activity, such as where the Earth's continental plates pull apart or collide. Volcanoes also occur far from plate lines in hotspots where the Earth's crust melts. Hawaii's volcanoes are examples of such hotspots. Volcanoes exist on all continents except Australia and also form in ocean trenches.
Alright, so far from this short video clip, we have learned a basic idea of what are volcanoes and where they are located. We learned that volcanoes are simply a vent or an opening in the ground through which escape to the surface ash, lava, and other volcanic material which comes out of volcanoes themselves. And we also learn that volcanoes are found basically in two main areas where plates, which you learned about in previous lessons, either pull apart, so therefore they create the openings in the crust or the ground for the volcanic material to escape to the surface, or where plates push together. You also learned about those areas of destructive or convergent plate boundaries, where obviously cracks and openings in the ground will be created by this crushing motion as plates push together, causing material to escape to the surface as well in volcanic activity. And then there are also other areas where they are away from plate boundaries, what we would call hotspots or thin areas of the crust where molten material called magma below escape to the surface through these thin areas of the crust, hotspots, such as in Hawaii, the islands found right smack dab in the middle of the Pacific Ocean. And we also learned so far that volcanoes are all over, but they are found all over except on the continent of Australia. So we continue this video.
The molten rock beneath the Earth's surface is called magma. Lava refers to the magma ejected from a volcano. Magma's mineral composition determines how its lava behaves. Mafic magma contains high concentrations of iron-rich minerals and magnesium. Mafic magma flows freely, producing lava capable of traveling some distance before cooling and solidifying. Felsic lava contains silica and produces thicker lava. Thick lava can't travel as far. Because felsic lava solidifies quickly, it produces the classic cone-like volcanoes, which are called composite volcanoes. Felsic magma can also solidify beneath the Earth's surface, creating magma chambers where hot gases and magma build up. This causes composite volcanoes to explode violently. Mafic lava produces a broad, low-profile volcano called a shield volcano. Instead of explosive eruptions, shield volcano eruptions cause lava to flow in all directions. Mauna Loa, a shield volcano on the Big Island of Hawaii, is the world's largest volcano, rising 13,680 feet above sea level. Seismologists classify volcanoes as active, dormant, and extinct. Active volcanoes are either erupting or likely to erupt in the future. Dormant volcanoes have not erupted in recent history. Extinct volcanoes have exhibited no activity for long periods and are unlikely to erupt in the future. And that's the hot news on volcanoes.
Okay, so you have learned some basic ideas about volcanoes from this short video clip. You have learned that volcanoes can be classified, or volcanic mountains can be classified into three basic groups based on their activity. Those that have erupted and are erupting in recent times, they have erupted in recent times and are still erupting, are considered active volcanoes. And we'll come to some of those in later parts of this lesson, where you'll see their location as examples. We have those volcanoes that have not erupted in a long time. They have erupted in past history, but in a long time they have not erupted and they are considered dormant, like they're asleep. And then there are those that have never erupted in all of history, recorded history that we know about, but we know that a volcano is there and a volcanic mountain was formed. These are considered dead or extinct volcanoes. We also learned from this video that there are two types of material called lava, hot molten rock that is melted, that comes out on the surface. There are two types. You have the very thick type and you have the very thin type. And based on the nature of that lava, it will determine the type of mountain that is formed around the volcano or the volcanic opening or the vent. And we learned that you have those that are called composite volcanoes. Those are usually very tall and they have layers of ash and lava laid out alternately. One layer of ash covered by a layer of lava, then you have another layer of ash covered by, and that you can count the layers to know how many times the volcano has erupted in the past, if you were able to cut through that volcano and look at the insides, that is. And of course you have the volcanic mountain that is formed from lava that is very thin and runny and spreads over a wide area. Therefore you have gentle sloping volcanoes or volcanic mountains because of the different type of material. You realize too that those volcanoes that tend to be formed, or the volcanic mountains that tend to be formed from the thin runny lava, are not very violent. They're very common in Hawaii, for instance. But those that are thick, they tend to pile up and close openings of the volcanoes and create pressure over time. And as the pressure builds up, these can be very violent and explosive and are the real killer volcanoes. And those are the ones that normally are the most destructive. So from this video we have learned basic ideas about volcanoes. Now, before we get into the details of this topic, let me share with you one last video clip. And so let me pause so we can get to that. Okay, so I want to share with you one last video clip before I get down into the real details of the lesson, which will introduce to you some of the other basic ideas related to volcanoes and their formation. So here we go.
Volcanoes mostly occur along destructive and constructive plate boundaries, where plates are pushed together or dragged apart. Cracks or weaknesses allow magma to rise up from below the Earth's crust. Pressure builds up, which then releases suddenly, causing the magma to explode. A volcanic eruption. Magma that reaches the Earth's surface is called lava. This molten lava eventually cools to form new rock. After more eruptions over time, a mound of rock builds up, forming a cone-shaped volcano. Volcanoes all have the same key structure. A collection of magma underneath the volcano forms a hot, bubbling furnace called the magma chamber. The main vent allows this magma to escape. And secondary vents are smaller outlets the magma can travel through. The caved-in surface is called the crater. It's created after an eruption blows the top off the volcano. Eruptions occur when pressure forces magma from the chamber up the main vent towards the crater. If the ash and mud from a volcanic eruption mix with rainwater or snow, it creates fast-moving mud flows. The hot lava and overwhelming mud flows can destroy huge areas. However, volcanoes are also essential for life on our planet. Scientists believe that volcanoes formed Earth's first atmosphere by spewing water vapor, sulfur dioxide, nitrogen and carbon dioxide into the air. And volcanic eruptions continue to contribute to the carbon cycle, crucial to life, by releasing carbon dioxide. They can go through long periods of being very active, but they may also become dormant, not erupting for hundreds or thousands of years. And eventually, they can become extinct, just leaving a cone-shaped hill that never erupts again.
Okay, so you have been introduced to, in very graphic videos, the basic ideas related to volcanoes. Now, on screen, the basic concepts as it relates to what a volcano is, as opposed to what a volcanic mountain is summarized for you. Please pause the screen and take a screenshot and store this in your notes for future study. So what is a volcano? You have learned already, but let me summarize it for you in note form. A volcano is an opening in the crust. And this opening, of course, extends from the surface all the way down to where the molten material is below. An opening in the crust through which escapes to the surface molten rock. Molten simply means that the rock is melted. It is so hot, intensely hot, that rocks literally melt and become liquid. Out of this opening comes molten rock, what is also called lava. Once it's on the surface, it's called lava. Ash, which you saw examples of that in St. Vincent. In other words, the rock and material down there has become so burnt up and powdery, so it comes down as ash. Hot mud, in other words, out of volcanoes can come heated water mixed with soil, and so it comes out as mud. Steam, in other words, the water that is coming from under the ground through volcanoes become boiling hot and therefore comes out as steam. And of course, various other gases which come out of the volcano, such as carbon dioxide, general smoke, carbon monoxide, nitrous oxide, all kinds of gases which come out of this hot burning phenomenon. Now, many people don't realize that there's a big difference, but in geography, there has to be made a distinction. There's a big difference between what a volcano is as opposed to what the volcanic mountain or cone is. Now, because the two occur together, people just simply call them the one named volcano. But in geography, a volcano is the opening through which all of this material which we spoke about earlier comes out. But then obviously as these solid materials and of course liquid and gas comes out, eventually all of the solid stuff will accumulate and pile up around the opening. And it is this piling up of the ejected material from the volcanic opening which forms a mountain or what is considered a cone. It's called a cone because it is shaped in a general idea like what a ice cream cone looks like turned upside down. So you have a pointed top and a rounded general surface, and it spreads out to form a circular object. So it's cone-like. Now the volcanic cone or mountain is what we normally see on the surface, and people call that mountain the volcano. But in geography, there's a distinction. The opening is called a volcano, and around that opening builds up the mountain or volcanic cone, which generally people call a volcano, but in geography, the distinction has to be made that is what is called a volcanic mountain or the volcanic cone. And so do not confuse the two. So I read on screen for you. A volcanic mountain or cone is a feature formed around the opening of a volcano after all the ejected lava, ash, volcanic rocks, and hot mud accumulate or pile up. So everything piles up that is solid, cools down, and forms this surface around the opening, which is what is called a volcanic mountain. Now, the world is filled with examples of volcanic mountains. And as we learned earlier, volcanoes are found in general zones of plate activity, where plates push together to create cracks and openings for stuff to escape on the surface, or where plates pull apart to do the same thing, material escape under the surface. But there are some areas that are not in active plate margins. They are away from plate boundaries, but those areas of the crust, they are thinner compared to other parts of the crust, and so material escape. These are called hot spots, such as way out in the Pacific Ocean where the Hawaiian Islands are found, which I'll show you shortly in the upcoming visuals. Now, examples of major active volcanoes that have erupted in recent times, these are just basic examples that are summarized for you in note form, include, there you have, La Soufriere, right here in the Caribbean, in St. Vincent. And I should point out that there are a number of mountains in the Caribbean which are called Soufriere. So in St. Vincent, we have in Guadeloupe another mountain called Soufriere, because this is a French word, Soufriere, which means sulfur opening or sulfur mountain. And several French-speaking islands of the Caribbean just happen to call their volcano in their countries Soufriere. So we have Soufriere, we have La Soufriere, we have in Montserrat, we have in Guadeloupe, and here in St. Vincent, examples of mountains called Soufriere. We have, of course, in USA, a major volcanic mountain that erupted in recent times called St. Helens. We have in Mexico, a famous volcano which was the only one in history to be observed from it started until it became a mountain. The very first day that the opening burst forth or opened up and stuff started coming out, Paricutin volcano in Mexico was observed from the first day by a farmer in his field until months after, years after, it became a monstrous volcanic mountain where all of the stuff that came out piled up, observed from beginning to its full formation. Fuji, or Fujiyama in Japan, another famous active volcano in the world. And of course, there are many other examples which you as a student will be required to know and be able to give examples in the continents and countries where they are located. Now, volcanoes are common, just reading the summary notes on screen, are common where crustal plates converge or diverge. You know these ideas already from past lessons, to create openings in the crust, or where molten rock below the crust, what is called magma, break through those thinner areas or weaker areas in the crust, what are called hot spots. These are away from plate margins. They are in areas where you have thinner sections of the crust, and therefore you have volcanic areas as well in hot spots. And so these areas of volcanic activity, they can form two types of volcanic activity. But before we get to the two types of volcanic activity, and by the way, let me point out here that all forms of volcanic activity, whether it be on the surface or below the surface, whatever feature it forms or whatever activities involved, once it relates to volcanic activity, this whole process and all the features formed above or below the surface is what we call volcanicity. Let me go back to that term that you saw earlier. There it is, volcanicity. In other words, all volcanic activity and all features formed, whether on the surface or below the surface. It's not just about volcanoes and volcanic mountains, but several other features which we'll come to. All of this is what we call volcanicity. Good. So we go back now to look at basically what a volcanic mountain in relation to a volcano, the opening, looks like. Please pause your screen and take a screenshot of the basic structure of what is called a composite volcano. This one is composite because it is formed from the thick lava which comes out first as a layer of ash as the volcano erupts, and a layer of ash comes down. Then a layer of lava pours out on that, and that's one eruption. In the next eruption, it explodes again. You have another layer of ash is laid out, and then pouring out on top of that, you have another layer of lava. And so over time, if you were able to cut through the middle of a volcano and look at the layers, you can count and see how many times the volcano erupted by simply counting the layers of ash or the layers of lava. So a composite volcano with the various parts is what you're seeing on screen. Please take a screenshot and make sure that you know the basic makeup or structure of what is called a composite cone or a composite volcano. Good. Now, the next thing we want to look at are areas in the world. So let me take you to some visuals. Areas in the world where volcanoes are very common. And if you notice, there's an area that is shaded red on this map. And you notice that it's actually surrounding a large body of water on the planet called the Pacific Ocean. Now, because active volcanoes and the major volcanoes of the world are located in this general area, notice it stretches all the way. Let's start from the right of the map. Stretches all the way, run through the left, the western side of South America, through Central America, the western side of North America, running all the way to the area of Europe, not Europe rather, Asia, the eastern side of Asia, continues through Japan, down to surrounding areas above Australia. And that area, you notice that it totally surrounds, or almost totally surrounds, the Pacific Oceans. That Pacific Ocean, that is where most of the active volcanoes of the world are located. And because of this area of active volcanicity surrounding the Pacific Ocean, it's actually called the Ring of Fire. Now, where did they get this idea of Ring of Fire from? Remember, volcanoes are features that produce molten rock, or out of which comes molten rock. And so molten rock is a fiery substance. And so zones of volcanoes which form this continuous area surrounding the Pacific Ocean is called the Ring of Fire, because it's a ring of volcanoes, as it were. And so if you zoom in on this map, you will notice that you can find some of the major active volcanoes of the world. There in North America, we have Mount St. Helens. There in Central America, where Mexico is, you have Paricutin, that volcano I spoke earlier of, the one that was observed from day one until it became a massive mountain. We have other examples in Mexico, such as the Popocatépetl volcano. Then you can zoom in on the Caribbean, and you can see example of Soufriere to the right of the map. There it is. Soufriere either in St. Vincent or in Montserrat or in Guadeloupe. Mountains all called Soufriere in the French language. You go down to South America, you can see active volcanoes like the Cotopaxi volcano in, I think it's Ecuador. And then, of course, you can, let me zoom out on this map and show you other areas. You can go over to the areas of the Philippines and Japan, all those areas, and see the active volcanoes that are there. You can recognize too that volcanoes are not just located just surrounding the Pacific Ocean, but they can be found, they are found in other areas as well, such as out in the middle of the Pacific Ocean. There we have the the most active volcano in the world, called Mauna Loa. That's found in the Hawaiian Islands, or the island of Hawaii. And this is not near a plate boundary. It's a hot spot. In other words, the crust is thin at that point and therefore escape the surface volcanic material. And this hot spot area is in the center of the Pacific Ocean, where the most active volcanoes, the Kilauea and the Mauna Loa volcanoes, these are the ones where material is just pouring out daily like out of a river. They are not explosive, but the material keeps pouring out at this hot spot. Most active volcano in the world, Mauna Loa. Tourists go there and see daily flowing out of lava, like you watch a river flowing down a hill. And so we have these major areas of volcanicity in the world. Let me take you to another map so you can see. Here we have in the Caribbean, right here in the Caribbean. And I'm zooming in on the Lesser Antilles. That's where the Caribbean plate is interacting with the American plate, or portions of the American plate. And because it's out in the Atlantic Ocean, they call it Atlantic plate. But it's still part of the American plate, North American plate. And so as these two plates push into each other, openings are created in the Eastern Caribbean, Lesser Antilles, and therefore material comes out to form volcanoes and volcanic islands. And there we can see major examples of active volcanoes in the Caribbean. I would advise you to take a screenshot of this as well, so you can see some of the common volcanoes in the Lesser Antilles and on which islands they are found. And so you can see, for instance, here is a Soufriere volcano, zooming in on the center of the screen, found in the island of St. Vincent, and of course its group called the Grenadines. You also have major island volcanoes in other islands, such as Kitemgeni. There we have another Soufriere volcano on the island of Guadeloupe in the center of your screen. There we have the Soufriere Hills in Montserrat, which was active just a few years ago, just like how St. Vincent is now actively spewing ash and creating real havoc in the island of St. Vincent. And so there we have examples of active volcanic zone in the Lesser Antilles, where a lot of volcanoes and volcanic material and volcanic features are found. Another map, there we can see a clear example of the Ring of Fire, the zone surrounding the Pacific Ocean, running all the way through Western South America, Central America, Western North America, going over to Eastern Asia, down through Japan, the Philippines, and surrounding almost the entire Pacific Ocean, the Ring of Fire. And so if you zoom in, you can see examples of some of these active volcanoes. There we have in Japan, for instance, Mount Fuji, or also called Fujiyama. There we have in the center of the Pacific Ocean, the Mauna Loa. You go over to North America, you can see examples of active volcanoes there, such as Mount St. Helens, the most famous one there in North America. Paricutin in Central America and Mexico. Cotopaxi in South America. And of course, when we zoom over to Europe, we have other major examples again, such as, that's to the left of the screen, Vesuvius, famous volcano in Italy. Mount Etna in an island called Sicily, just off the coast of Italy. Stromboli, another active volcano in Italy. And so there are so many active volcanoes in the world that I will leave you, the student, to learn examples and be able to give their countries and continents, be able to give these on your own. And so these are the general areas of volcanic activity. Now we have basically covered the basic concepts of volcanoes and volcanic mountains and basic volcanicity. What I want to do now is to extend the lesson further into more detailed study on volcanoes. And this time around, instead of explaining, I'm going to share with you notes on screen, which as we scroll through slowly, my advice is to read and also take screenshots and make sure that you are taking full note of the information related to volcanoes. So now the rest of this lesson will be dedicated, the next 2 or 3 minutes, I'll be sharing with you additional material on screen, which you are expected to pause the screen, take screenshots, make short notes of these very vital pieces of information. Now, on screen you can see I'm showing you information from a text on geography, CSEC geography, and we know that the word volcano comes from the Roman god of fire who was Vulcan, and because of course he lived underground where the magma and the lava came from, according to the myth, and so they named volcano after Vulcan, the god of fire. And as you can see, basic definition of a volcano is a vent or opening in the crust. Let me go to that area where these notes continue, from which pour molten rock debris. In other words, all the stuff that pile up and accumulated gases and steam. And so I'm scrolling slowly through the information. Please make sure that you read along or take screenshots as you so desire, screen captures. All right, here we have terms that you need to be acquainted with. Please take a screenshot and make this a part of your notes. At the bottom of the screen, all material that comes out of volcanoes are called pyroclastic material. Pyro, prefix which means fire or related to fire. And so materials coming out, pyroclastic material. Let me go to the rest of the notes where that is continued. Please make note of these important concepts. And of course, during volcanic eruptions, you can have major earthquakes because of the violent eruption, which cause the sea to be pushed onto the land, giant sea waves because of the massive vibration of the ground. So it pushes the seawater onto the land, which can drown coastal areas, called tsunamis. Notice the spelling. It's a Japanese word. Very important concept to keep in mind. Continue to share with you important information. Please read, take screenshots, make note of. And of course, volcanoes categorize into 3 groups based on their activity. Those that are active, recent eruptions have taken place, and it will erupt again in the near future. Dormant, those that have not erupted in a long time, but they have erupted in the past. They are asleep, as it were. And then volcanoes which are considered dead and may never erupt again. Of course, nobody can guarantee. A dead volcano can just suddenly, because of what is happening on the ground, pressure building up for centuries, and can still erupt. But generally, volcanoes which are considered dead, they have never erupted in history, and it is assumed they will never erupt again, are considered extinct. Sharing with you general information which can be helpful in your study on volcanoes. Now, this is coming from a text, so unrelated information is popping up to the left and right of the notes. You can ignore that for now, but everything that relates to volcanoes, I'm sharing with you on screen. So, you remember me saying earlier that there are 2 types of volcanic features, those that are under the ground and those that are above the ground or on the surface. So here we are learning that those which are underground, hardened magma can form special features underground. And I'm scrolling through so you can read and of course take screenshots. And here's a nice diagram summarizing features formed underground and also features formed above the surface. So if you notice on the surface you have a volcano. That is obviously a feature that is above the ground and is therefore called an extrusive volcanic feature. Extrusive features that are above, outside of the ground. Extrusive. Lava flow is another extrusive feature. Lava flows up onto the surface and hardens and sometimes can form a flat-topped mountain called a plateau. But then there are other features on the surface that are extrusive, which can be like, for instance, a hot spring. Hot water flowing out of the ground from an area of volcanic rock, and so the spring is generally warm or hot, so you have a hot spring. Sometimes the spring can explode onto the surface as hot steam shooting feet up into the air, and that happens every now and then. It's called a geyser or geyser, G-E-Y-S-E-R. These are all extrusive volcanic features. So volcanic mountains, lava flows on the surface, hot springs, explosive hot springs called geysers, all extrusive. But then you notice that there are some features which can be formed underground from the hardened magma below the surface. So there you have, for instance, the batholith, the dike, the sill. Feel free to do further research on these, but the basic ideas of what they are in the diagram as well as in the summarized portion of notes that you're seeing on screen. Now, here we have extrusive features, types of lava, which you learned earlier about the thick and the thin lava. Notice that you can have different terms describing the same thing. Felsic lava, mafic lava. You can go back and watch the earlier video clip and compare what was described as mafic and felsic compared to what is described as acidic or basic lava in this portion of the lesson, in the notes you're seeing on screen. So these are all that you're seeing on screen are all features that are formed above the ground. Make notes, take screenshots, store them in your notes on your device. Now, of course, we have different types of volcanic mountains based on their makeup and based on their structure. I advise you to take screenshots and learn the details and compare that with the notes you're seeing on screen. Everything that is appearing on screen is important as part of the study. And here we have examples of real volcanoes in the world, right here in the Caribbean, that a case study of them was done. Read through and get additional information. St. Vincent, active volcano, erupting in 2021 as we speak. Here there is a case study of this island and its volcanic features and volcanoes. Additional information which can be helpful in your study of volcanoes. Now here we come to notes on the underground features formed by hardened magma. Important information, please take screenshots, make notes, carefully read. All of this is meant to give you additional information as you go through your study on volcanoes. Here we have another example of a case study of a real volcano that is active in the island of Montserrat, also called Soufriere. Important information on screen. Read through, make screenshots, and store and study to aid in your general study of volcanoes and volcanicity. That, of course, students, bring us to the end of this teaching video. Please rewatch, make short notes, take screenshots, do further research on your own, compare what you have learned in the video with what you read elsewhere, whether you may want to read Britannica Encyclopedia Online about volcanoes, or Wikipedia, or just generally Google volcanoes and the concepts related to volcanoes. And success to you as you study volcanoes and volcanicity, features that are all related and processes that are all related to volcanoes. Features which are above the ground, extrusive; those that are below the ground, intrusive. But all part of the science called volcanicity or volcanology. Thank you for listening. Success to you.